Okay, so today we're doing the notes that says rock types and then looking specifically at igneous rocks. So we already looked at minerals. Minerals are basically put in groups based on their chemical composition. So if it has silicon and oxygen, it's a silicate mineral. If it has calcium and carbon, it's a carbonate mineral, and so forth. Rocks are put into groups based on how they form. So rock types are classified by their origin. Now another difference between rocks and minerals is minerals are basically the building blocks of rocks. So minerals are what rocks are made out of. So for example, the analogy I like to use is like bricks in a brick house, all right? Even though a brick house is made out of bricks, brick and a brick house are two different things. So if I held up a rock and said, that's a nice mineral, that would be like looking at a brick house and saying, that's a nice brick. Or if I picked up a mineral and said, oh, it's a nice rock, that's like picking up a brick and saying that's a nice house. It doesn't make sense. But anyways, so we're focusing on rocks today. Now, since rocks are classified by their origin, there's basically three ways in which rocks can form. And we're going to quickly identify all three of those, and then we're going to look at one of those in more detail. So first and foremost, igneous rocks. Rocks that form from cooling and solidification of molten or melted rock. So that's one that people typically think of with rock formation. And people a lot of times think of, a volcano erupting and the red lava cooling and hardening. That's an igneous rock, and that's what we're going to look at in more detail today. But the other two types of ways in which rocks can form, sedimentary rocks form from the hardening of sediment. All right, so basically like little pieces of rock. It could be pebbles, it could be sand, it could be clay particles, little pebbles, particles that are cemented or packed together to make a rock. Now it's usually rock fragments. It could be animal parts. When I say animal parts, I don't mean like a heart, liver, or lung. I'm meaning like seashells or teeth or something like that, hard parts. There are some rocks made entirely out of animal shells. But anyway, so it's to be parts of the rocks, little pieces stuck together. Now, sedimentary rocks, because they're made of particles that are cemented together, this does not need to take place at high temperature. Igneous rocks are associated with a lot of heat. Sedimentary rocks can take place at low temperatures. When you make cement, it's a man-made sedimentary rock. You don't need really high temperatures to make cement. Okay? We'll look at sedimentary rocks in more detail on another day. Metamorphic rocks. Rocks formed from already existing rock being exposed to heat and pressure. Now, if I take a rock and I heat it up, not so hot that it's melting, but if I get it up close to the melting point temperature, some of the characteristics of the rock will change. So much so that it becomes a entirely new rock. Or if I take a rock and I expose it tremendous amounts of pressure, I could change some of the characteristics of that rock. Again, so much so that it's considered a new type of rock, and that's what a metamorphic rock is. But we'll look at the metamorphic rocks in more detail on another day as well. So what we're focusing on today are the igneous rocks. Now, one of the key characteristics that's common with igneous rocks is most igneous rocks have interlocking crystals. So what that basically means is that the crystals kind of fit together like puzzle pieces. So there's no gaps between the crystals, they're interlocking. So that's a characteristic commonly found in igneous rocks. Now, when I look at igneous rocks, one thing I can notice about them that's different between a lot of them is sometimes they have really big crystals and other times they have really small crystals. And what determines that is how fast the melted rock cools and hardens. And what determines that is where the rock formed, right? Now, there's basically two things that determine what kind of igneous rock you have. One, the thing that determines the texture of the rock is how fast it cooled, which is determined by where it cooled. And the other thing is what kind of magma you have, because there's more than one type of magma. So those two things combined is what gives us the variety of igneous rocks that we have. All right. But for right now, let's just focus on the where the rock is cooling. All right. So some igneous rocks are what we call intrusive. or also called plutonic, all right? Plutonic, named after Pluto, the Roman god of the underworld. These are the rocks that cool beneath the Earth's surface. So intrusive rocks result in slow cooling of magma beneath the Earth's surface. Slow cooling allows large crystals to form. The slower it cools, the more time the crystals get to form, the bigger the crystals get. So like with my example here, without the caption underneath it, I could tell that this one cooled more slowly than that one did, because this one has big crystals and this one has little crystals. So the slower it cools, the bigger the crystals are. The faster it cools, the smaller the crystals are. Okay. So intrusive rocks form underground. So if, let's say here's a volcano. Intrusive rocks are the ones that are cooling and hardening down here, and they have a coarse texture. They have large crystals as a result of them cooling very slowly underground. Right. Now, the volcano erupts, the molten rock comes out of the ground. All right, that's what an extrusive igneous rock is. All right, or also called volcanic. Volcanoes are called volcanic from the god Vulcan, god of fire. Rapid cooling of lava at the Earth's surface. All right. Now, first off, if I look over here, it talks about slow cooling of magma beneath the Earth's surface. And here it says rapid cooling of lava at the Earth's surface. There's a reason why one of them says magma and one of them says lava. The difference between magma and lava is magma is down underground. All right. Magma is melted rock down underground. Once that magma comes up and comes out of the volcano, now it's called lava. All right. So the name just tells you where it's located. Magma's underground, lava's above ground. All right. But anyway, so the melted rock comes out of the volcano. The stuff that cools at the surface is what we call extrusive. So extrusive igneous rocks would form up here, comes out, erupts, and then comes down. Fast cooling results in small crystals. All right. Now, when I say small crystals, what that means is the crystals are basically small enough where you're not seeing it with your naked eye. If you can see the crystals with your naked eye, it's considered relatively large crystals. All right. So just to give you an example, these two rocks right here are basically made of the same stuff. It's just that this one cooled slowly and this one cooled fast. So this one here, I could see the individual crystals. I could see the pink crystal there, the white crystal there, the black crystal there. I could see all the individual crystals in this. This has a coarse texture. This one right here, I cannot see the individual crystals. There's crystals, but they're really, really tiny. You have to like look through a microscope or something to see them. So this would be an example of a fine texture. That is one that cooled fast outside at the Earth's surface. That's extrusive. This one cooled slowly under the ground. So I had a chance for all these crystals to form and get really big. So underground, intrusive; above ground, extrusive; coarse texture, fine texture. All right, so again, if it cools slowly, I get big crystals. If it cools fast, I get small crystals. Now, sometimes it cools really fast and crystals don't get a chance to grow at all. Very fast cooling can produce a glassy texture, and a glassy texture means there are no crystals. All right, so a glassy texture would look like that. So basically, looks like a black piece of glass. So there are no crystals in this. The crystals never got a chance to form. All right, so that is a glassy texture. That means it cooled really fast. All right. Or if it cools really, really fast, you can get what's called a vesicular texture, all right, or a sponge-like texture. Now, when a volcano erupts, it's a lot like opening a bottle of soda, all right? there's gases that are in the magma. All right, you open the cap up, and the soda comes out, and you see all the bubbles and stuff come out with the soda. Well, same thing with a volcanic eruption. When the volcano erupts, the lava comes out, it has gas bubbles in it too. Now, usually it's still a liquid and the gas bubbles escape. But just imagine if I was opening up a bottle of soda, like especially like root beer, because root beer is normally extra foamy. If I was opening up root beer and the foam came out, and then I froze it instantly, so the bubbles didn't get a chance to pop and just return to like a liquid. It just was foam and it froze instantly. What I would end up with is like an ice that had a bunch of air pockets in it. Well, kind of the same idea here. When the lava's got a bunch of gas bubbles in it, if it cools really, really fast, those gas bubbles get trapped in the rock and you end up with a sponge-like texture, which is what we call vesicular texture. And this right here would be an example of a vesicular rock. So all those little dark things, those are little holes in the rock, little gas bubbles or gas pockets that are in the rock. So as a result, this rock has a fairly low density because of all the gas pockets in it. Right? Now, this rock here is another example of a felsic, or another example of a vesicular rock. Now this one you really can't see the air pockets too much because they're really small. This is a piece of the rock called pumice, but this one has such a low density because it has so many gas pockets in it that if I put it in water, pumice actually floats because it has all those gas pockets in it. It has very, very low density. All right, so if the rock's extrusive, I can either have a fine texture, which means small crystals. I could have a glassy texture, which means no crystals, or I could have a vesicular texture, which means that there's a bunch of gas bubbles in it. All right. So this here determines what kind of texture the rock's going to have. Now, the other thing that determines what kind of igneous rock you're going to have is what kind of magma you have. Now, there's basically two types of magma. You have felsic magma and mafic magma. The reason why there's two types is they have slightly different chemical compositions. Felsic magma has lots of aluminum and silicon in there. Mafic has lots of iron and magnesium in there. As a result, this one here is darker in color. This one, when this cools and hardens, it gives you one set of minerals that are darker in color. This one here gives you another set of minerals that are lighter in color. These minerals here have a higher density, so mafic rocks are more dense, felsic rocks are less dense. Where you typically find felsic rocks is on the continents. Where you typically find mafic rocks is on the ocean floor or in the middle of the ocean. So like when the volcanoes in Hawaii erupt, Hawaii is in the middle of the ocean, the rocks that come from there are very, very dark in color because that's a mafic composition. But if you had like a volcano erupt in like Washington State or Mexico, those rocks, when that magma cools and hardens, that's going to give you a lighter colored rock because it's on the continents. It's a whole different set of minerals. All right, so there's a chart in your reference tables that deals with this that we use to identify various igneous rocks. And that chart is on page 6. And it is this chart right here. All right, so this is on page 6 of your reference tables. So here are the names of the various igneous rocks right there. Intrusive, so these are the ones that cooled underground. Extrusive, these are the ones that came out of the volcano. Over here, crystal size. So the biggest crystals, the relatively big crystals, the small crystals, the no crystals. The texture, glassy, fine, coarse, very coarse. Vesicular, again, with the gas pockets. Non-vesicular means no gas pockets. Down here, the color, the ones on this side of the chart are lighter in color. The ones on this side of the chart are darker in color, generally. Density, these ones here have relatively low density. These guys here have relatively high density. Composition, over here, these are the felsic ones. So they have lots of silicon and aluminum. These guys right here are the mafic ones. They have lots of iron and magnesium. All right. Now down here, it shows you what minerals you can expect to find in these rocks. So for example, in a piece of granite, all right, if I want to know what minerals to find in granite, I just come straight down from granite. So granite usually has potassium, feldspar, quartz, plagioclase, feldspar, biotite, and amphibole. Those are the minerals you find in granite. In a piece of diorite, the minerals I'd expect to find in diorite is plagioclase, biotite, amphibole. So those are minerals I'd find in diorite. Or a piece of gabbro, that's mostly going to be plagioclase, pyroxene, olivine, maybe a little bit of amphibole. So you just find the name, come straight down underneath, and that tells you what minerals you expect to find in that rock. Now, sometimes you may see, like, especially if you're looking at like granite countertops, you may see a bunch of different types of granite countertops where they look substantially different from each other. And the reason for that is the compositions can be a little bit different. So what I mean by that is, let's just use granite as an example. This whole block here is granite. But if I'm looking at a granite over here, what I'm going to find is this granite is going to be almost all potassium feldspar with a little bit of quartz and a little bit of plagioclase, biotite, and amphibole. So it's like 70% is potassium feldspar, which is white to pink in color. Quartz is clear to white in color. So granite over here on the chart would be, that would be a very, very light colored granite. All right. Whereas a granite over here on the chart, it's still granite. If I come down, that's only going to have a small amount of potassium feldspar. It's going to have a lot of quartz, a lot of plagioclase, a lot of biotite, and a lot of amphibole. These two minerals here are usually black in color. This is white to gray, white. But you know, this is going to be like almost half black colored minerals. So this one would be a much darker shade of, or darker version of granite than that one could. So like that and that, they're made of the same minerals, but the amount of those minerals is different. It's still granite. Both of them are still granites, but the amount of the minerals is different for granite on this side of the chart to granite on that side of the chart. All right. All right, so that's how you read the igneous rock chart.